The second conic that we're talking about right now is going to be parabolas. And we've seen parabolas before, but there's some pieces that we want to kind of add into it that actually give it its shape and its structure. So previously, we've gone over the idea of an axis of symmetry, which divides it down the middle. And we've also talked about the vertex, which goes through the axis of symmetry and is kind of the midpoint of that parabola, or the highest or the lowest point. But really the structure of a parabola comes from these two things, which are called the focus and the directrix right here. Okay, the focus we want to understand is a coordinate point, got it, and the directrix is actually a line. And you can kind of see from the diagram what happens is the structure of the parabola is created because the distance between the focus and the graph is the same distance from the graph to the directrix. So same thing if we look in here. The distance between the focus and the vertex is going to be exactly the same distance as the vertex to the directrix. Another thing to kind of point out is that that focus is always engulfed kind of inside the parabola, and that directrix is going to be, again, a line on the outside of it. We can kind of take a look at this example over here. Let's see if I can get it more in the window. There we go. The focus, you can see that this length right here is 4.23. This length is 4.23. And as I move the point along, that distance, although it changes, is consistent, meaning that they're the same from the point to the focus and the point to the directrix, even if it changes length. So again, that point to the vertex, they're going to be exactly the same. Now, as we move the focus and the directrix, you'll notice that the parabola changes. So again, it gives shape to it. So, moving the focus closer kind of makes it more narrow. I can do the same thing with the directrix. I can move the directrix away, or I can move it closer, and it really kind of affects that shape of that parabola. While we've seen different forms of a quadratic that produce a parabola, we're going to look at kind of one other form, and that really kind of stems from the idea of a vertex form. So if we look and think of a vertex form like this, y equals a times defining x minus h squared plus k, if you recall, the points and the variables kind of play off of each other in the sense of h makes it go left and right, whereas k makes it go up and down, and the a is the width. And again, I'm going to just assign with the vertex is 0, 0. But if the a is positive, the parabola opens upward, and we know that that focus is on the inside, and that directrix will be on the out. Now, these should technically be the same distance, but I'm just kind of giving you a sketch. Now, what WebAssign is going to have you kind of format this as is they're going to have it look like bringing the k over to the other side. So it's really going to be this idea of x minus h squared equals 4p times the quantity y minus k. So part of that is just swinging that k over, and this idea of 4p comes from that distance from the focus. So p is that distance between the vertex and the focus, and that's how you kind of calculate part of that a. The directrix, as you'll notice in this case, is a horizontal line, so that is y equals, and it's going to be k minus p, because if we look at that vertex, that y value, I'm going down, so I'm going to subtract that value of p, and the focus right here can be calculated by doing h, because that's how far we're moving left and right, but again, that height is different, so it's k plus p. Now, we're just going to look at this from a few different angles. Let's say that it was y equals negative a x minus h squared plus k. What's going to happen with this is that it's going to open downward, because that's negative a, and that focus is going to be on the inside and that directrix on the outside. Again, because that directrix is a horizontal line, it's going to be y equals k minus p. It's kind of that distance. And that focus is going to be h comma k plus p. Same kind of formula for horizontal. Now, what's a little bit different than what we've talked about before is this idea of it going side to side. So if you think about if we change it up and go x equals a y minus k squared plus h. H and k are still the vertex, okay? So it's still the vertex, h is still the x, y is still the, k is still the y. And the same sort of thing, the directrix is going to be that line on the outside, and the focus will be on the inside of the parabola. Well, there's a little bit of difference here. This directrix now is vertical, so it's x equals, and it's going to be h minus p. Again, h comes from this part, that vertex, okay? And the p is the distance from here to here. And now the focus is going to be calculated by h plus p comma k. Because again, from the vertex, the height didn't change, so that's why the k is the same. But the x value did. It moved over that much. Again, in WebAssign, how you're going to format this is you're going to plug it in as y minus k squared equals 4p times the quantity x minus h. So it's technically not an a anymore, but it's going to be based off of the p. We'll look at this one more time going this way. Same thing for the focus and the directrix as far as how you calculate it, but just to kind of see what's going to happen, focus is on the inside, directrix is on the outside. Again, vertical line going up and down, so x equals. What you can see in the notes right here is this is the format that you're going to want to use for WebAssign. Okay, you see that quantity of x minus h squared equals 4p. Again, write this down. P is that distance from the vertex. You can kind of see that right here. Oops. Okay. P units from that vertex to do that calculation. We rearrange these kind of in that vertex form, just like we did before, to kind of help us calculate this. So you see how this is in standard form right here? What's gonna slightly change is we want to get rid of that fraction. So we're gonna get y equals let's do -2. So if I multiply by -2, we're gonna get -2y equals x squared plus 2x minus 1. And we want to put it in vertex form. So if you recall this, what we do is we kind of use that completing that square method. We swing the constant over to the other side. And what I'm going to do is I'm going to complete the square. So I got to figure out what I add to both sides that will make this a PST. And we do that by doing b divided by 2 squared. B is 2 in this case, so it's going to be 1. So I keep it balanced by adding 1 on both sides. What we're going to do is we're going to make this a PST on the right. Sorry, this should have been a +1 right here. So now what I have is -2y plus 2 equals that quantity x plus 1 squared. And what we do with this is we're going to divide out the -2, so we get y minus 1 equals the quantity x plus 1 squared. So this is the form you'd put it in to WebAssign. And this gives me a couple of things. First of all, this tells me the vertex. The vertex is -1 that comes from here, and then the +1 comes from here. Now, what they asked for, though, is they asked for the focus, and the focus gets calculated by h comma k plus p. So the h is -1, that doesn't change. Here's my h, here's my k. But this time it's going to be k, which is 1, plus some number. Well, we don't know what p is. Where does p come from? It comes from this right here. So what we're going to do is we're going to take that coefficient, -2, and set it equal to 4p. Okay, that number equals 4p, divide by 4, p equals -1/2. So I'll go back over here, add the -1/2, and that focus then is -1 and 1/2, and that's kind of where that focus is.